In this sequence, we are going to show you how the names of the components can be adapted to the specifications of your plant. We will set up the hardware configuration of the S7400 automation system and the ET200M distributed I/O system, along with defining the symbolic addressing of the signals for the individual input-output modules. In the new multi-project, the wizard has created a SIMATIC station, which will now be configured in the component view. First, the name of the PC station is adapted to the name of the PC. This helps to simplify engineering in distributed automation solutions with several OS servers. Now the computer is configured with HWConfig. This integrated part of PCS7 allows you to configure PC stations and automation systems. The configuration is carried out according to the previous basic PC configuration in what we call the Station Configuration Editor. A WinCC application has already been inserted in Index 1. The Ethernet adapter is inserted in Index 5. The address is entered in the Ethernet adapter properties. Finally, the adapter is assigned to a network. The configuration is now completed. It is compiled and downloaded. HWConfig is now closed. In the new multi-project, the wizard has automatically created an automation station, which should be renamed in the component view so that it can be better identified. Next, the system hardware configuration and layout is performed. First, the S7400 station is renamed so that it can be identified better in AS1. It's recommended to name the controller after the process areas it is to be used to control. The name of the S7 program is adapted to the AS name. Now the automation system is configured. In the first step, we check whether the preset hardware components in the wizard match the actual components. First, the rack is checked. The part number matches the actual hardware. Now the power supply is checked. The part numbers don't match. For this reason, those part numbers are replaced by those of the actual modules used in the system. The configured CPU matches the actual component. Next, a communications processor CP443-1 is inserted for Ethernet communication. Now, various settings are defined in the Properties dialog. First, the ISO protocol is activated, and the MAC address is entered. The IP protocol is not used. For this reason, it is deactivated. Finally, the communications processor is assigned to the system bus network. The CP443-5 extended is configured for access to the Profibus. Again, some adjustments are made in the Properties dialog. The first step is to create a new Profibus string, which will have the name DP1. The last step is to open the Properties dialog with the right mouse button and to set the CP operating mode to DP Master. The S7416 automation system hardware is now fully configured and has been assigned to the system bus network. An ET200M distributed I/O system with an address of 3 is connected to the Profibus DP segment called DP1. It will be configured in the next step. In the first step, the IM153-2 is added to the Profibus string DP1. The address is set to 3. The ET200M is equipped with an analog input, an analog output, a digital input, and a digital output, which will all be configured. The analog input module is plugged into slot 4. This module is included in the catalog of hardware that is optimized for use with PCS7 v60. The analog output module is plugged into slot 5. This module is included in the standard hardware catalog. In this profile, you can find all modules that are supported by and are compatible with SIMATIC PCS7. However, we recommend that you work with the PCS7 v60 catalog, since it contains the subset of available hardware modules that are optimized for use with PCS7 v60, and therefore enables you to work more efficiently. The digital input module is included in the PCS7 v60 catalog. It is plugged into slot 6. The last module to be configured is the digital output module in slot 7. In the hardware configuration, the IM153-2 interface for the ET200M distributed I/O system was inserted into the rack and communication was set up. The ET200M rack was expanded with analog and digital input-output modules based on the hardware that is to be used on the project. In order to use symbolic addressing of I/O throughout the configuration, instead of rack slot channel numbers or memory locations, each address is given a unique symbolical name and comment in the Edit Symbols dialog. The Edit Symbols dialog is activated to enter the symbols. The symbol name PVIN of controller 1 is entered in the first line as well as in the comment column. This is done by copying the symbol name to the clipboard and pasting it into the comment field. The corresponding symbol name of controller 2 is entered in the second line as well as in the comment column. The corresponding symbol name of the current value of the manipulated variable controller 1 is entered in the third line as well as in the comment column. The corresponding symbol name of controller 2 is entered in the fourth line as well as in the comment column. The dialog is completed by clicking OK. The symbolic names of the analog input signals have been defined and assigned to the channels of the module. Next, the symbolic addressing of the analog output module's channels will be assigned. Again, the Edit Symbols dialog is opened for entering the symbols. The symbol name of the controller 2 output is entered in the first line as well as in the comment column. The corresponding output of controller 2 is entered in the second line as well as in the comment column. The dialog is completed by clicking OK. Symbolic names have now been assigned to the channels of the analog output module. The symbolic addresses of the digital input module are assigned in the same manner. Again, the Edit Symbols dialog is opened. The symbol name of the feedback signal ON of motor 1 is entered in the first line as well as in the comment column. The corresponding symbol name of motor 2 is entered in the second line as well as in the comment column. The symbol name of feedback signal OPEN of valve 1 is entered in the third line as well as in the comment column. The symbol name of feedback signal CLOSED of valve 1 is entered in the fourth line as well as in the comment column. The symbol name of feedback signal OPEN of valve 2 is entered in the fifth line as well as in the comment column. The symbol name of feedback signal CLOSED of valve 2 is entered in the sixth line as well as in the comment column. The dialog is completed by clicking OK. Symbol name has now been completed for the digital input module. The last step is to assign the symbolic addresses to the channels of the digital output module. The Edit Symbols dialog is again opened. The symbol name for switching motor 1 on-off is entered in both the first line as well as in the comment column. The corresponding name for motor 2 is entered in both the second line as well as in the comment column. The symbol name for opening or closing valve 1 is entered in the third line as well as in the comment column. The corresponding name for valve 2 is entered in the fourth line as well as in the comment column. The dialog is completed by clicking OK. The assignment of the symbolic names for the channels of the digital output module has been completed. All of the required symbolic addressing has been defined. In later configuration steps, you will be able to easily make use of these symbolic names without having to reference physical addresses. A named connection is set up to ensure reliable communication between the operator station and the automation system. It is configured from the NetPro interface. NetPro is started. In order to define the named connection, the WinCC application is first selected in the SIMATIC station. All existing connections are displayed in this table. A new connection is created by double-clicking on an empty cell. This is the CPU to which we want to define the connection. In the Properties dialog, the name of the connection is changed to OS1 AS1. No further information is required. Now the changes must be saved and compiled. The compilation has been carried out without errors. Now the hardware configuration and the named connection are loaded into the AS. The AS is selected with the left mouse button and is then loaded. The CPU is again set to Run status. In the last step, the named connection is loaded into the SIMATIC station. The WinCC application is selected and the connection is loaded. NetPro and HWConfig are terminated. The hardware-specific part of the configuration example is now finished. You are now ready to begin configuration of the actual application program.